Hello. Did you have your breakfasts? Here is the new problem. We are 7. Let's wait a little bit more. While we are waiting, we can read the question. It's a system problem again. Solve the system in the set of real numbers. For x squared over 1 plus 4x squared is y. For y squared over 1 plus 4y squared is z. And for z squared over 1 plus 4z squared is equal to x. Solve the system in the set of real numbers. I have, you saw the first part of the problem, x, y, z. They're all positive numbers. From where we got this conclusion, guys? Because if we check the equations, perfect square has to be greater than 0. It has to be greater than 0. It's greater than 0. So y has to be greater than 0. By the same way, 4y squared is greater than 0. The denominator is greater than 0 as well. So z has to be greater than 0. By the same way, 4z squared is greater than 0. And 1 plus 4z squared is greater than 0, which means that x is greater than 0. Now, how to solve the system? Most of you are here, so try to solve it, guys. What do you think? How to start? What can we do first? How to start to solve the system? If we add them all, the sum of x, y, z is going to be 4x squared and 1 plus 4x squared. I've add all the equations, you see. And now here, if we take them all, the ones on the left side, if I take them all to the right side of the equation, we'll get this. 0 is equal to 4x squared over 1 plus 4x squared minus x. By the same way y, the same way z. Can you please try to simplify this expression? I don't want to show you the next step. Can you please try to get the next step, guys? If we write each term as a single rational expression, how is it going to be? Are we going to be able to get perfect squares at the end? Can you hear me? I hope you're solving, that's why you cannot write anything. Hoo-hoo. Okay. Nice, you hear me. Guys, I want you to write the next step on your own. That's why I'm waiting. In this sum, if I can get perfect squares in numerator, square of a number has to be greater than or equal to 0. So if the sum is equal to 0, we can easily find the solutions of the system. There will be only one possibility. The numerators are 0, and then we'll be able to solve the problem. So let's see how it looks the next step. If we write each group, each term as a single rational expression, 4x squared minus x minus 4x cubed. The second one, 4y squared minus y minus 4y cubed. The third one, 4z squared minus z plus minus 4z cubed. Now, can we factorize? What's the common factor in the first one? You see, x is the common factor. Y is the common factor. Z is the common factor. Let me take x, y, and z out of brackets in each term. So what do we have in the first one? In the first one, we'll have negative 4x squared plus 4x minus 1. It looks like a perfect square, right? But there is a problem. It's minus times a perfect square. Here by the same way, minus 4y. Actually, 4y squared minus 4y plus 1 is the perfect square. But we have multiplied every term by minus. I will move it to y. I will move the minus 1 here, the common factor minus 1 to x. And in the last one, by the same way, I'll move minus 1 here. So in the next step, we are going to have minus x times 2x minus 1 squared. Look, this is 2x minus 1 squared times minus 1. So I have written that minus here. Minus x times 2x minus 1 squared. Here, by the same way, minus y times 2y minus 1 squared. And by the same way, z times minus z times negative 4z squared plus 4z minus 1 is 2z minus 1 squared. And did we get perfect squares in numerators, guys? Yes, we did. Minus x times this, minus y times this, and minus z times this gives us 0. I mean, minus x times, of course, 2x minus 1 squared over 1 plus 4x. The sum of these three rational expressions gives me 0. How can it be possible? if we check the terms, if we check the factors, x, remember at the beginning we said that x has to be, y has to be z, x, y, z, they are all positive numbers. From where we know? Because we know the system y, z, x. Look here, positive, positive, y has to be positive. Positive, positive, z is positive, 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 x is positive. So x, y, z, they are all greater than 0. So if x is greater than 0 and 1 over 4x squared is greater than 0, this expression is going to be greater than 0 if 2x minus 1 is greater than 0. So there is only one solution for this problem. The numerators, 2x minus 1, 2y minus 1, and 2z minus 1 are going to be 0. Or x, y, z is going to be 0. Is it possible? At the beginning, we said that it cannot be possible. So here, if 2x minus 1, 2y minus 1, and 2z minus 1 are 0, then x is 1 over 2, y is 1 over 2, and z is 1 over 2. Or another solution, x, y, z are 0, but is it possible? No, it is not possible because x, y, z are positive numbers. Any question? Did you miss any step here? Oh, wait a second. Why do we say just positive numbers? Why don't we say greater than 0, not positive? Greater than 0 or equal to 0, because x can be 0 here, right? If x is 0, y is going to be 0. And if y is 0, z is going to be 0. If z is 0, x is going to be 0. So we will have the third case. Let me change it. Here in this step, I said that they are supposed to be 0 or greater than 0. So there are these cases. X, y, z are 0, 0, 0. This is also a solution. I skipped this. X, y, z. What makes 2x minus 1 squared 0? 1 over 2. So each variable is 1 over 2, or each variable is 0. So these are the solutions of the problem. The system has two solutions. X, y, z, they are all 0, or x, y, z, they are all 1 over 2. Is it clear? Did you get the factorization here? This part of the problem. Any question? Is it clear? Okay, then I'm changing the question. Who got it? This is the end. Here the solutions are. Let's write it mathematically. Solution set is 0, 0, 0, or 1 over 2, 1 over 2, 1 over 2. Is it clear? Is it clear just for Christina? Angela, thank you. Philip, Dimitar, Damian, Sandra, Monica, Spase, Ariania. It's easy. Good. Okay, let's see the next problem then. Okay, Monica, quickly copy the question. This is the question. Okay. Let's see the next problem now. Thank you, sir. Solve the system in the set of integers. This question is from Sigma 105, and also they asked it in Obstinsky, 2016 Obstinsky. Solve the system in the set of integers. X squared minus y is z squared, y squared minus z is x squared, and z squared minus x is y squared. It is not that hard, and they asked it in Obstinsky, you see. So you can solve it. Oh, I forgot to rotate my paper. I finished all white papers at home. I was using this paper. The hint for this question, you can add them all. When you add them all, you will get the sum of x, y, z. And it will help you to solve the problem. A very useful equation. Yeah, x, y, and z is 0, right, Damian? The sum of x, y, z is 0. Yes. It's a very useful equation now. Where can we use that x plus y plus z is equal to 0? This is one of the solutions, Christina. Yes, you got one of the solutions, but we have more. One solution is they are all 0. By the way, from the first lesson, I have written Philip and Christina for Milka. I promise when I come to Republic, when we meet there, I will give your chocolates. Philip has 1, Christina has 1. Are you solving? May I start to explain? Christina got 1 solution, 0, 0, 0. Did anyone else get solutions for the system? One more minute. Okay, I'm waiting. Can we start? Christina, do you get new solutions? Did you get new solutions? Okay, let's start, guys. What did we say first? If we add them all, we get that x plus y plus z is equal to 0. Now, if we say that x is equal to minus y minus z and substitute this in the second equation, what are we going to get? If we substitute it in the second equation, we'll get that y squared minus z is equal to square of this. If I square, it doesn't matter whether it's minus or plus, y squared plus 2yz plus z squared. Now here we can dig y squared and y squared. So the simplest form of the expression is going to be z squared plus 2yz and z. If I factorize it, it will be z times z plus 2y plus 1 factors of this expression. So how many cases do we have? If the product is equal to 0, then z is equal to 0 or z is equal to, bravo, Vlatko got another case. That's correct. Z plus 2y plus 1. Let's solve it for these cases. If z is equal to 0, then if we check, if z is equal to 0, if we check a, x is going to be negative y, right? X is going to be negative y. And in 1, if I substitute this, let me remind you 1. In 1, if I substitute it, it will be y squared minus y is equal to 0. Z is 0 and x is equal to minus y. I substitute them in first equation. So I got y squared minus y is equal to 0. From here, y is 1 or y is 0. If y is 1, then what will be x? X will be minus 1. And if y is equal to 0, then x is going to be 0 as well. So what did we get from the first case? We got these two solutions. X is equal to minus 1, y is equal to 1, and z is equal to 0. Here is the first one. And the second solution, the one that Christina got, 0, 0, and 0. Z is equal to 0. We got two solutions from the first case. Now from the second case, if z plus 2y plus 1 is equal to 0, then z is going to be negative 2y minus 1. From A, where is A? X plus y plus z is equal to 0 is A. From A, if we substitute this, x plus y minus 2y minus 1 is going to be 0, which means that x minus y, the difference of x and y, is going to be 1. Can I write it like x is equal to y plus 1 and then substitute it in the third equation? Why in the third one? Because I know z in terms of x and y. I know x and y, so I have x and y, so I can write the equation in terms of y. Z is equal to negative 2y minus 1 to the power of 2. In the third one we substitute. And minus x, which is minus y plus 1, is equal to y squared. Here we got a quadratic problem with y. If I simplify this problem, we will get 4y squared plus 4y plus 1 equal minus y minus 1 equals y squared. And when I simplify this, I will get 3y squared, and 3y is equal to 0, which means that 3y times y plus 1 is 0. From here, the roots are minus 1 and 0. Y is equal to negative 1 and y is equal to 0. Let's go back. If y is minus 1, what will be x? X will be 0. If y is equal to 0, x will be 1. And what was z? Z was given in terms of y, so I have to substitute. If y is minus 1, z is going to be 2 minus 1, 1. And if y is equal to 0, then z is going to be minus 1. So we have two more solutions. I have written it here. If y is minus 1, x is 0, and z is 1. So 0 minus 1, 1 is one solution. And if y is 0, x is 1, and z is minus 1, 1, 0, minus 1 is another solution from the second case. So how many solutions did we have for this problem? For the system, we have 4 different solutions. One is negative 1, 1, 0. One is 0, 0, 0. One is 0, negative 1, 1. And the last one is 1, 0, and negative 1. Is it clear? Is there any question? If you want, I can show it from the beginning once again. Vlatko, he got one more case, so I want to write on my list also his name for chocolate. Vlatko. What did we do? First we said that if we add them all, x, y, z is going to be 0. Then we can substitute. I choose x is minus y and minus z, but if you want, you can use y is equal to minus x minus z, and then substitute it in the first one, and then get an equation in terms of what, x or y. So here, what did we get? I chose x, x is minus y and minus z. If I substitute it in the second one, we'll get this equation. When we factorize, we get z is 0 or z is minus 2y minus 1. So for the first case, if z is equal to 0, when I substitute z in A, x is going to be negative y. And if x is negative y, let me substitute these two in the first equation. Z is 0 and x is minus y. When I substitute in the first equation, I got that y squared minus y is 0. So y is 1 or y is 0. If y is 1, x is minus 1. If y is 0, x is 0. So the solutions from the first case, x is minus 1, y is 1, z is 0, or they are all 0. And then from the second case, minus 1, 1, 0, 0, 0, 0, or 0, minus 1, 1, or 1, 0, and minus 1. Can I show you the next problem? Okay, let's see the next problem. Guys, is there any connection problem? 3 minutes. Can you hear me? Do we have any connection problem? Okay. For which we had. If Damian doesn't have, maybe it's from your internet. Can you hear me now? This one. I think it is from competition last year or 2017. And this is from last year's sigmas. No, this year's sigmas. I have copied this exercise from this year's sigmas. I'm not sure from 110, 111 or 112. It looks simple, and it is really simple. It's a linear system, as you see. For which values of m does the system have solutions such that x is greater than 0 and y is smaller than 0? How to solve the problem? X has to be positive and y has to be negative. For which values of m, x is going to be positive and y is going to be negative. It is really simple. What are you supposed to do? To write x and y in terms of m, then check for which values of m, x is going to be greater than 0, and for which values of m, y is going to be smaller than 0. First, you are supposed to write x and y both in terms of m. Yes, Vlatko, you are right. Nice. Vlatko got one more question before I solve it. M has to be smaller than 15, and one more value we have for m. It has to be greater than what? Smaller than 15 and greater than Monica, Sandra, Leshev, Spase. I'm waiting for the solutions. Angela, Giovanna. Who else? Damian, Christina, Philip. Aryan, is Aryan here still? Are you here, Aryan? Okay. Bravo, Vlatko. You solved it. M is greater than 4 and M is smaller than 15. You're right. One of you solved the problem. Let's solve. It is not that hard, guys. You will say, when I solve the problem. Right. I said I will try to write x and y in terms of m. To be able to write it in terms of m, first I chose y. To get y in this system, to dig x, I will multiply the first equation by -3 and the second equation by 2. So we'll get -6x plus 15y is -30 and 6x -4y is 2m. So we can dig them. What left? Y is equal to 15 minus 4 is 11. 11y is equal to -30 plus 2m, which means that Christina is also done. Good. Y is equal to -30 plus 2m over 11 in terms of y. By the same way, if you substitute this in the equation, or if you multiply the first equation by -2 and the second equation by 5, you will get x in terms of m. Here I used substitution method. 2x minus 5y is equal to 10. In the first equation, if I substitute this y, 10 plus 5y over 2, 10 plus 5 times, when I substitute -30 plus 2m over 11 over 2. When you simplify this, it will be -20 plus 5m over 11, x in terms of m. Y is -30 plus 2m over 11, and x is -20 plus 5m over 11. And the question says x must be greater than 0 and y must be smaller than 0. So the first one, x -20 plus 5m over 11 has to be greater than 0. For which values of m it will be greater than 0? If m is greater than 4. By the same way, -30 plus 2m here. -30 plus 2m over 11 is going to be smaller than 0. For which values of m? If m is smaller than 15. So if I write the solution set for m, m has to be greater than 4 and smaller than 15 to have a solution where x is greater than 0 and y is smaller than 0. This was an easy one, right? Here I will show the solution part. Is there anyone who didn't get it? No one. Good. Good. So can I show you the new problem? Okay. So 10th problem for today. 10th problem is coming. Yes, Damian? One more time, why not? Damian wanted to see the previous solution once again. Here it is. Damian, write down. Damian, here. Minus 20 plus 5m is greater than 0. So minus 20 is greater than minus 5m. So m is greater than 4 for the first one. And for the second one, minus 30 plus 2m has to be smaller than 0. And then minus 30 minus 2m. Remember, if you divide both sides of the inequality by a negative number, you have to change the sign. So m is going to be smaller than 50. Okay. I thought here you have mixed it. Okay, then in the new problem, this problem is from this year's sigmas. I don't know from which one, but one from 110, 111 or 112, I don't know. They want us to write the quadratic equation, possible cases of this equation, if the difference of the roots is 7 and the difference of cubes of the roots is 91. We have very useful two equations. Yeah, we can find determinant, or we can find by Vieta, we can find sum and product of the roots. They may help us. And by the way, here maybe I can remind you difference of two cubes, this formula. I know you remember, you know it, but let me remind just in case. x1 minus x2 cubed. How do we expand this? This is x1 cubed minus x, let's write first 3x1 squared x2 plus 3x1 x2 squared and minus x2 cubed. So you can write x1 cubed minus x2 cubed as x1 minus x2 cubed minus x1, 3x1 times x2 in brackets what? x2 minus x1, right? You can use this identity to solve the problem. Here, I will leave it. Be careful, guys. You know x1 times x2 in terms of q, and x1 plus x2 you can write in terms of p. And you know difference of the roots, you know difference of cubes. What did you get? Did you get something useful? To be able to determine the quadratic equation, we need to find p and q, right? So in other words, we are asked to find possible values of p and q. Okay, let's start to solve it together. 2 minutes, okay. Is that enough? Can you, by that equation, Vlatko, can you write the equation, the quadratic equation? X squared plus px plus q. You got the relation between p and q, but that's not enough to write the equation. This equation I'm talking about. Q is negative 36. A factor of negative 36, but not negative 36. Let's start to solve it. Huh? May I? May I start to solve it? Okay. First of all, I will factorize this. X1 cubed minus x2 cubed. X1 cubed minus x2 cubed. Difference of two cubes. I gave you that way, but I factorized by the other. Okay, never mind. X1 minus x2 times x1 squared plus x1 x2 plus x2 squared. How to write this in terms of x1 minus x2? Here we have x1 cubed minus x2 cubed is 91. x1 minus x2 is 7. And x1 squared plus x1 x2 plus x2 squared is 91. 7 of x1 squared plus x1 times x2 plus x2 squared is 91 over 7, which is 13. 13 is equal to x1. Yes, Christina got the value of q. That's correct. Damyan, you also got it? Bravo. I'm writing names, guys. Okay. So if 13 is x1 squared, x1, x2, x2 squared, let's try to write q in terms of this and x1 minus x2. Okay, q. x1 times x2. Product of the roots is q. So how can we write x1 times x2 in terms of these two equations? So first, if I write this x1 squared, x1, x2, x2 squared, then I have to subtract to get x1 times x2. I have to subtract x1 minus x2 squared and divide it by 3. If you want, I can make this step clear. Here we have x1 squared, x1, x2, x2 squared minus x1 squared minus 2x1, x2 and x2 squared over 3. So the simplest form of this expression is going to be x1 squared minus x1 squared. We divided them. Here it will be positive if I simplify brackets, and it will be negative. Divided. We have 1 x1 times x2, 2 more x1 times x2, so 3 times x1 x2 over 3. It will be q, as you see. So if I write x1 and x2 in terms of these two, I will get 13 minus 7 squared, which is negative 12. You see, we got q. Q is negative 12. If q is negative 12, now I will try to calculate p. P is sum of the roots, right? P is sum of the roots. And if we square both sides of the equation, p squared is going to be x1 plus x2 to the power of 2. I'm squaring this because I can write this perfect square in terms of x1 minus x2 and x1 times x2, which is q. So if I try to write it in terms of them, it will be x1 minus x2 to the power of 2 plus 4x1 x2. From where? From x1 squared minus 2x1 x2, x2 squared plus 4x1 x2 gives me what? 2 times x1. Oh, sorry. x2, x1 squared and x2 squared, right? It gives me the perfect square of x1 plus x2. So this expression, we know x1 minus x2, it is 7 squared plus 4 times product of the roots. In the previous step, I got product of the roots, that's negative 12. So 7 squared plus 4 times negative 12 gives me 1. P squared is equal to 1 and Q is equal to negative 12. If P squared is equal to 1, what are possible values of P? P is positive or negative 1. So if P is equal to positive 1, the equation is going to be x squared plus x minus 12. And if P is equal to negative 1, it will be x squared minus x minus 12 is equal to 0. And this is the answer of the question. They just want me to write the possible equations. Is it clear, guys? Do you have any questions? Maybe they will ask it this year in Obshtinsky, because it's from this year's sigmas. That's an easy one. I think it's enough for this exercise. Can I change it? Okay. Next problem is coming. It's another system problem. Next one. Solve the system in the set of real numbers if x squared plus y squared is 6, x cubed plus y cubed is 14. Oh, sorry, it's not a system problem, excuse me. X squared and y squared is given, x cubed and y cubed is given. We are supposed to find x to the power of 4 and y to the power of 4. It's easy, right? It's not that complicated. You have to just remember the identities for x cubed plus y cubed, x4, y4. For example, if you square the first one, you will get something related to x to the power of 4 and y to the power of 4. That's a solvable question, just you need to be careful and you need time. So far today, Philip solved 1 question, Christina solved 3 questions, Latko 2 and Damian 1. Okay, did you write it before I start to solve the problem? Maybe I missed, I haven't seen your writing. Okay, I haven't realized then. Philip has 2, Christina has 3, Latko has 2 and Damian has 1. Spasi, you don't have to get the first place. Don't worry, we'll eat chocolates in our Olympiad lesson. Yes, that's useful, Damian. 36 minus 2x times, what have you written? 2x squared y squared. Yes, that's useful. How is it going? What did you get so far? Damian got 36 minus 2x squared y squared. What about the others? What have you done? Okay, Christina, waiting. Does the problem have two solutions? Yes, it does. It has two solutions. There are three cases. From one case, there won't be any real solution. From first and second cases, we will have solutions. What are solutions? Can you please write? Philip, what did you get for x to the power of 4 and y to the power of 4? Okay, I'm waiting. What is 34? That's right. Yes, it is. 34 is a solution of the x to the power of 4 and y to the power of 4, but there is one more. Okay, guys, time is so fast. Let's start to solve it. 47 over 2. I have an irrational expression. Okay. The first x to the power of 4 plus y to the power of 4 can be written, I forgot square here, can be written in terms of 6, which is x squared plus y squared. X to the power of 4 plus y to the power of 4 is square of x squared plus y squared minus 2x squared y squared, which is here 6 to the power of 2, which is 36 minus 2 times xy squared. And if I factorize x cubed plus y cubed, I will get x plus y times x squared minus xy plus y squared, which is, here I can substitute x squared and y squared in the equation, x plus y times 6 minus xy. As you see, I got two equations in terms of sum and product of x and y. 36 minus 2xy squared is x to the power of 4, y to the power of 4, and x cubed plus y cubed. From this equation, I got this. X plus y times 6 minus xy is equal to 14. Now, in this equation, if I assume that x times y is equal to t, then x plus y is going to be 14 over 6 minus t. X plus y, the sum of x and y is going to be 14 over 6 minus t. And let me try to write x, y. Look, I got x times y and x plus y in terms of t, the same variable. Let me use this identity now. X squared plus y squared is equal to x plus y squared minus 2 times x times y, which is 6, right? Which is 6. So if I substitute x plus y and x times y in terms of t, I will get this quadratic equation. 14 over 6 minus t squared minus 2t is 6. And if I simplify this quadratic equation, square this 196 over 36 minus 12t plus t squared minus 2t is 6. 196, when you multiply, when you get a single rational expression, 196, negative 72t plus 24t squared minus 2t cubed over 36 minus 12t plus t squared, and cross multiplication now. After the cross multiplication, we'll get 196 minus 72t. In both sides we have, I will dig them, 24t squared minus 2t cubed, and 6t squared is 6t squared plus 216. When I simplify, when I take all the terms to the same side, we got this, not that ugly. We'll get this beautiful cubic equation. And now 2t cubed minus 18t squared plus 20. If I divide everything by 2, I will get t cubed minus 9t squared plus 10. Yes, isn't it? 14 squared. And look at coefficients of this cubic equation. 1 minus 9, 10. If you add them, one 9, 10, it will give me something if I substitute 1. Let me check 1. Is 1 a solution of this problem? 1 cubed is 1 minus 9. Sorry, minus 1. I'm checking minus 1. Minus 1, 9, 10. Yes. So if t equals minus 1 satisfies this equation, I can easily factorize it as t plus 1 times t squared minus 10t plus 10. How did I get t is equal to minus 1? 1, 9, 10. So I wanted to check 1 and minus 1. One of them probably will satisfy this equation. I have checked 1, I failed. Then I checked minus 1. Because of the coefficients, I chose 1 and minus 1. 1, 9, 10. It can be simplified. So if I use t is equal to minus 1, it will be a solution of the problem, which means that t plus 1 is a factor of cubic equation. And then by polynomial division, yesterday I remind you how we divide polynomials. T cubed minus 9t squared plus 10. If you divide it by t plus 1, you will get t squared minus 10t plus 10. So from here we have two solutions, right? T is equal to minus 1, or t squared minus 10t plus 10 is equal to 0. From the first solution, if t is minus 1, and then I will check if t is, when you solve this quadratic problem, t is 5 plus or minus root 15. So I will check all possibilities now. If t is minus 1, let's remember what was t. Remember, let's go back. T is equal to x times y. So if x times y is equal to minus 1, if x times y is equal to minus 1, what will be x to the power of 4 by using this equation? Now I will show it. Yeah. By using this equation, if x times y is equal to minus 1, x to the power of 4 plus y to the power of 4 is going to be 36 minus 2 times 1, which is 34. This is the first equation. I don't remember, but I think Damian got it. Huh? 34 is one solution. Then if x is equal to, from the second case, if t is equal to 5 plus or minus root 15. Let's assume first t is 5 minus root 15. What will happen if t is 5 minus root 15? That means x times y is 5 minus root 15. Again, if I use this equation, x to the power of 4 plus y to the power of 4 is 36 minus 2 times xy squared. Square of this expression will be 40 minus 10. And if you simplify, it will be 20 root 15 minus 44. This is the second solution for x to the power of 4 and y to the power of 4. And the third one will be if t is equal to 5 plus root 15. If t is 5 plus root 15, that means xy is 5 plus root 15. And again, I'm going to substitute in that equation. X to the power of 4, y to the power of 4 is 36 minus 2 times square of this. What will be square of this? It will be 40 plus 10 root 15. And 36 minus 2 times 40 plus 10 root 15. If you simplify this, x to the power of 4 plus y to the power of 4 is going to be negative 20 root 15, negative 44. And is it possible? They are both even powers. X to the power of 4 has to be greater than 0. Y to the power of 4 has to be greater than 0. How can it be smaller than 0? The right side of the equation, it is not possible. So, did all you guys, can you hear me now? Can you hear me now? Okay. Okay, let me finish it. I will explain the last part once again, if you lost it. From the third case, if xy is 5 plus root 15, when you substitute xy in this equation, in x to the power of 4, y to the power of 4, in that equation, if we substitute, we will get that x to the power of 4 plus y to the power of 4 is a negative number, which is not possible. So there is no solution from the third case. There are two solutions for this problem. X to the power of 4 plus y to the power of 4 is equal to 34, or it's equal to 20 root 15 here. 20 root 15 minus 44. We have only two solutions for this problem. Let me show it from the beginning once again. You said you lost. We were given x squared plus y squared, x cubed plus y cubed, and we are asked x to the power of 4 plus y to the power of 4. First, we try to write x to the power of 4, y to the power of 4 in terms of x squared and y squared. So how to write it? Square of x squared plus y squared minus 2x squared y squared, which is 6 to the power of 2. 36 minus 2 times xy squared. And if I substitute, if I factorize x cubed and y cubed, x cubed times y cubed is x plus y times x squared minus xy plus y squared. This is by the identity. And we know that x plus y times x squared and y squared, we know from the first one, 6 minus xy. So we got x plus y times 6x minus, 6 minus x times y is equal to 14. We don't know the value of x to the power of 4, y to the power of 4. So instead of first one, I will try to write an equation in by the second one. X plus y times 6 minus xy is 14. So let's write, if x times y is equal to t, let's write x plus y in terms of t. It will be 14 over 6 minus t, right? And look, both x times y and x plus y are written in terms of the same variable, t. Can I use this identity now? X squared plus y squared is equal to x plus y squared minus 2xy, where I have t and 14 over 6 minus t. If I substitute them and simplify this equation, we will get a cubic equation, which is here. This part is just addition, subtraction, and division. No, up until here there is no division. I will divide in this step. I will wait just if you haven't written yet. Okay, now if we got this cubic equation, 0t cubed minus 9t squared plus 10, I need to factorize this cubic equation. I have checked 1 and minus 1. Minus 1 satisfied the equation, so t plus 1 has to be a factor of this cubic equation, which means that we can write the equation in that form, t plus 1. If you do polynomial division, it will be t plus 1 times t squared minus 10t plus 10, which means that there are two solutions for t. T is equal to minus 1, or t is equal to, if you solve this quadratic, you will get 5 plus minus root 15. I'm not writing all the steps here. From the second quadratic factor, you will get 5 plus minus root 15. Now we check solution for t. If t is minus 1, what was t? T is x times y. If t is minus 1, we substitute x times y is equal to minus 1 in this equation, because this is x to the power of 4, y to the power of 4 is equal to 36 minus 2 times xy squared. So x to the power of 4 plus y to the power of 4, 36 minus 2 times 1, which is 34. If x times y is minus 1, x to the power of 4 plus y to the power of 4 is going to be 34. For the second case, we had two roots, 5 plus minus root 15. First, I'm checking for 5 minus root 15. If x times y is 5 minus root 15, x to the power of 4 plus y to the power of 4 is going to be 20 root 15 minus 44. When you substitute in this equation, x to the power of 4, y to the power of 4, 36 minus 2 times square of this will be 40 minus 10 times root 15, and the simplest form will be 20 times root 15 minus 44. And if x times y, which is t, if x times y is 5 plus root 15, when you substitute again in this equation, you will get x to the power of 4, y to the power of 4 is equal to minus 20 times root 15 minus 44, which is smaller than 0, which is not possible, right? X to the power of 4, y to the power of 4 cannot be smaller than 0. So there is no any solution from the third case. We got two solutions for this problem, 34 and 20 root 15 minus 44. I think it's enough for this question. Let's see the next problem. Next problem is a question from regional. I'm not sure, but it's probably from last year. last year regional. A times x plus y minus 1 is equal to x minus 2y minus 1. And a times x minus y minus 3 is equal to x plus 2y minus 3. Solve. A is an integer here. Solve the question in the set of integers. Solve the question in the set of integers. How to solve it? Do you have any idea, guys? How to start? How to start? By the way, thank you for likes. Subtract the equations. Why not? We can subtract them, we can add them. Yes, you can write A in terms of x and y. Why not? But while I'm solving the problem, before I start to solve, I will change the system a little bit. Wait a second. X minus, opa. What did you write, Christina? X minus 2y minus 1 over x plus y minus 1 equals... Okay, what do you get from here? It would be easier to solve it by that way, Christina, if you have common terms here. X plus y, x minus y, there is nothing to dig. Is A 1? Yes. One of the solutions of A is 1. But there are 3 more cases for A. Yes, Angela, you're right. Your equation is also correct. Spase, you got one of the solutions. A, if A is 1, x is going to be x and y. Can you tell me what are x and y if A is equal to 1? This is one of the solutions. A is equal to 1. Can I start to solve it? Wait, okay. Okay, try please. I'm waiting. Lotko, what are those solutions? Yes, Pastor, that one is correct. If a is equal to 1, x is going to be any real number and y is going to be 0. Lotko, you said you have 3 solutions. What are they? X is 2, wait a second. X is 2, y is 0. There is a little mistake, but it's okay. And x2, y2, a is minus 3. And a is 1, y is 0, x is, yes. There is one more case, but I will write you one more. Let's go. I don't know how you started, but I wanted to change the equation a little bit. I start, guys. I start to solve the problem. The system is given in this form, but it will be hard a little bit to add, to subtract the equations. So I wanted to write it, the variables of x and y in terms of a. So can I write the system in this form? From the first one, I have a minus 1 times x, a plus 2 times y, a minus 1. If you simplify this, the coefficients of x and y in terms of a will be a minus 1, a plus 2y. And the second one, if I do the same, a minus 1x minus a plus 2y equals 3a minus 2. And then if we add the system, we will get that 2 times a minus 1x is equal to 4a minus 4. And if we subtract them, if we subtract these two, we will get 2 times a plus 2y equals minus 2a plus 2. Now from the first one, if a is not equal to 1, if a is not 1, then x is going to be 2, right? If a is not 1, then x has to be 2 to get 4a minus 4. But if a is equal to 1, x is going to be any real number, because 2a minus, if this is 0, 4a minus 4, x is going to be any real number. And from the second case, from the second equation, if a is equal to minus 2, then, first I have solved it for a is not minus 2. Let's solve it for if a is not minus 2. If a is not minus 2, then y is going to be minus 2a plus 2 over, 2 times a plus 2, which is minus a plus 1 over a plus 2. If you dig 2's, it will be minus a plus 1 over a plus 2. I know that x, y, and a, they are all integers. So let's write this rational expression in this form. Minus 1 plus 3 over a plus 2. Can I write it in this form? Because I want to check possible integer values of a? Yes, I can. So what will be positive or negative or integer? Let's say integer factors of 3 here. A plus 2 can be positive or negative 1, and a plus 2 can be positive or negative 3. So I have to check all these cases. First case, a can be, if a plus 2 is minus 3, then a can be minus 5. If it can be minus 3, it can be minus 1, it can be 1. Do we have any common case from first and second? In the first one I got, if a is 1, then x is going to be any real number. So you see, we have 4 cases. A is 1, I will check it from the second one. A is minus 5, a is minus 3, or a is minus 1. So let's check the first one. If we check the first one, a is equal to minus 5. When I substitute a in the system, I will get that in which system? In this system. Can you see it? Not in the first form, in this form. If I substitute a, x is going to be 2 and y is going to be negative 2. By the same way, if I substitute minus 3, x is going to be 2 and y is going to be negative 4. If I substitute minus 1, x and y both, they will be 2. And if I substitute 1, x is going to be any real number, y is going to be 0. Is there any question? Is it clear? I will show the solution from the beginning, step by step. What did we do? First, I have written the equation in this form. I tried to write the variables of x and y in terms of a. So when I write in this form, when I add the equations, I will get 2 times a minus 1x is 4a minus 4. And if I subtract them, I will get the second form. And then from the first one, I'm checking. If a is not equal to 1, then x has to be 2. But if a is equal to 1, then x is going to be any real number. This is one case. And from the second equation, if I check if a is not minus 2, then y is going to be minus a over a plus 1 over a plus 2. That can be written in this form, and which is minus 1 over 3, minus 1 plus 3 over a plus 2. A plus 2 is going to be plus minus 3 plus minus 1. So a is going to be minus 5, minus 3, minus 1, 1. And what if a is minus 2 in the second case? I forgot to check it. What will happen if a is equal to minus 2 in the second one? If a is minus 2, then is it going to be a solution? Does it satisfy? If a is minus 2, does it satisfy the equation? Let's substitute. 2 times 0 plus times y is equal to minus 2 times minus 2 plus 2. On the left side we have 0, on the right side we have 6. Does it satisfy? No. So a cannot be minus 2. It has to be different than negative 2. So we got values for a plus 2. A plus 2 is going to be minus plus 3, minus plus 1. A is going to be minus 5, minus 3, minus 1 or 1. Then how what? I didn't check the previous messages, so can you please repeat? Is there any problem? Yes, 0 is not equal to 4, that's why we do not have any solution. 0 is not equal to 6, so a cannot be minus 2. That's why I have checked only -5, -3, -1, and 1. When you substitute them, -5, -3, and -1 in the system, in this system. Guys, do we have a problem, connection problem? Can you hear me? Can you hear me? What happened? Where did you go? 7. Okay, you're back. Is there any question from this exercise? This is a regional problem. We solved the problem. We solved the system in the set of integers where the variable a is an integer as well. We got a is -5, x is 2, y is -2. Okay, a is -3, is -1, a is 1. So we solved it in the system for each a value. It is done. Can I solve you? Oppa. Okay, I go down to copy the last part. Guys, I know time is over, but if you let me quickly, I will solve one more problem. Or if I can just show you the problems that I was planning to solve for today, and you can try to solve them at home. These are all from Sigmas. You can find the solutions. If you cannot solve them, you can find the solutions in Sigmas. These are the problems that I was planning to solve. These 3. I couldn't finish them, but you can copy them. One is from Sigma 111, one is from Sigma 112. You do not have the solution for this exercise, but we have solved similar problems, similar to this. Solve a problem in the set of integers. You can try to solve this and prove that the equation has no solution in the set of integers. No, I won't solve you the solutions. That's the easy way. That's the easiest way. Please try to solve. You can find the solutions in Sigmas. And this is the third problem. Is not that hard. I want you to try to solve them. You have the first question in Sigma, the solution you have. 14th one, you do not have the solution. If you do not have Sigma 113, you do not have the solution for this, but I solved you similar exercises, so you can solve the second one by yourself. And the 13th one, x minus y cubed, y minus z cubed plus z minus x cubed is 13, has no solution in the set of integers. These 3 problems are for homework, then we can finish it here. Nice to meet you guys. Nice to meet you, everyone. I will bring chocolate to all these students when I come to Republic. Philip, Christina, Vlatko, and Damian. They all tried. So I'll bring chocolates to each. Nice to meet you. See you. Good luck in Obshtinsky, in Regional, in Republic. I hope all you will go to the last step. Why not? IMO.